In this video we'll cover the basics of hydraulic circuits and actuators associated with them. Now, hydraulics comes from two Greek words, the hydro word referring to water and the olus word referring to pipe, and so we're talking about water pipes or fluid that's actually going through a pipe. In hydraulics, and particularly in hydraulics actuators that we'll be using, we're looking at using an incompressible fluid, typically some sort of an oil that's non-corrosive, because we don't want to cause rust inside of our actuators and things. And we pump this fluid around our system. Now, as it's incompressible, we can have very, very high pressures. These pressures are very high, relating to a very high force, but typically this is a very, very low speed. And so these things aren't particularly fast, particularly compared to what we have in electric and pneumatic actuators. Our pressure, though, is in the order of hundreds or thousands of psi, so much, much larger. And the oil that we pass around there has a few different functions associated with it. Firstly and foremostly, it transmits power and allows things to be actuated and move back and forward. Because it's an oil, though, it also lubricates the system. And so that's a very useful thing for us. And in our pneumatic systems, we injected a small amount of oil into the air. And it finally dissipates the heat. And it acts essentially as a massive heat sink, and as it circulates around the system, it can remove heat from various parts of the system as well. Our basic circuit consists of, we see there a reservoir full of oil or the sort of liquid that we're using, and we have a filter associated with it that we filter. There's a hydraulic pump there that will pump the oil around our system, and a control valve there which allows us to select where we'll actually be pumping the oil to. Is it going to go, for example, into this inlet of the actuator or this inlet of the actuator? We then have our actuator, and that actuator, consisting of a cylinder and pistons, may have several different inlets that we can pump the actual oil into. We actually have the hydraulic oil to begin with, and a baffle in there that we put between the inlet and the outlet. This baffle will go into the reservoir and stop turbulent flow and things occurring within our reservoir. The oil will go back into the reservoir and then be pushed back around the system by our pump that we have there. So typically our most common applications using hydraulics are where we require high force. So things like presses, and I've seen the large hydraulic presses that they use to press out dashboards and instrument panels at Continental down in Bandura. Lifting mechanisms where we're trying to lift heavy things like cars, for example. Tractors where they need to lift large amounts of forces. A single hay bale, for example, is 500 kilos, and they need to be able to lift normally one of them on the front and one of them on the back as they cart them around the farm. And other associated heavy machinery that we might have there. And essentially we're leveraging off Pascal's law and gaining mechanical advantage by having different sized cylinders here and being able to pump these things around and lift large masses.